Alright, in this video here, we're going to take a quick look at the addition and subtraction formulas for the sine, cosine, and tangent functions. So notice, all of these formulas involve a sine, s plus t, or sine, s minus t, and then same for cosine and tangent. Right, so what these formulas are used for is if you know like the trig functions of two angles. So let's say I know sine of 45 degrees and I know sine of 30 degrees, right? Because I know those from the unit circle and from my trig hand. So if I know 30 and 45 degrees and I know the sine of those and the cosine of those and all that, well, if I add 45 plus 30, that's 75 degrees. So I can use this formula to find the sine of 75 degrees by making 75 degrees 45 plus 30, and then plugging in those numbers 45 and 30, and then I do all those calculations, I get the sine of 75 degrees. Or if I make it 45 minus 30, I can find the sine of 15 degrees, right, by plugging the numbers 45 for the s and 30 for the t into that formula there, right? And then same ideas with the cosines and the tangents. So these are used for when you know two angles, you know the trig functions for those two angles. If you add or subtract those two numbers together, you can use these formulas to find the sine, cosine, and tangent of the sum or difference of those two angles that you already know. All right, so that's generally how these formulas come into play. Also, you could use them, it does come up every once in a while. You'll be doing a problem, like if you saw the videos that I did recently on simplifying trig expressions or proving trigonometric identities. Every once in a while, you'll be doing one of those problems, and you'll come out to something that looks like this: tangent s plus tangent t over 1 minus tangent s times tangent t. And you can say, oh, well, that's one of these formulas that's equal to tangent of s plus t. So let me do that to simplify this further. So you can do that as well. I mean, they don't come up that often in that context, but it could happen that you're doing a problem and you get cosine s cosine t minus sine s sine t. Okay, that equals cosine s plus t. Right? So you can use it in that respect as well to simplify things. All right, so the formulas are up here just real quick to run through them. Sine of s plus t equals sine s cosine t plus cosine s sine t. Sine of s minus t is almost the same formula. It's sine s cosine t minus cosine s sine t. All right, so you notice the addition and subtraction formulas for each one of the functions, they're similar to each other, but there's usually like one difference in there for one's addition and one is subtraction. All right, cosine of s plus t is cosine s times cosine of t minus sine of s sine of t. And then cosine of s minus t is cosine s times cosine of t plus sine of s times sine of t. All right, again, very similar formulas, but what changes is that plus and minus in the middle, just like up here for the sine, the plus and minus changes. All right, and then tangent of s plus t is tangent s plus tangent t divided by 1 minus tangent s times tangent of t. Tangent of s minus t is tangent s minus tangent of t over 1 plus tangent of s tangent of t. Right, so these formulas, depending on what class you're in and who your teacher is, some teachers make you memorize all these formulas, others don't. Usually in the classes that I teach, I don't make my students memorize these formulas. I just show you these formulas so that you are aware that they're out there, and if you ever do need them, you just look them up and find them and use them there. Right? Something I said in one of the previous videos I did, there are a ton of formulas that we use with trigonometric functions, and some we use all the time, like the reciprocal formulas and like the sine squared plus cosine squared equals 1. Like those come up all the time that you should memorize those and you should know them. In my opinion, other ones like these don't come up very often, and it's not worth wasting your time memorizing all these formulas. Most mathematicians who do this stuff regularly don't have every single one of these trigonometric formulas memorized, but they know that they exist. So they know that if they have to do cosine of s plus t, there's a formula for that, and let me look it up real quick and find what it is, and then I know how to use it when I have to. So I know that it exists, and I know how to use it if I need to use it. But as far as memorizing the formulas, to me, it's not always that necessary. Now, depending on who your teacher is and what class you're in, they may say you have to memorize all these formulas, in which case, have fun doing that. All right, so I'm going to pause the video here and just do one quick example where I just pick one of these formulas, and we'll just to see how one of them works. And if you can do one of them, you can do any of the other ones. You just have to put the right stuff in the right place. All right, so let me put that example up here. All right, so I left up here the first formula because that's the one that we're going to use to evaluate sine of 75 degrees. All right, so to evaluate sine of 75 degrees, one option is to use the calculator, which is how I normally would do this if I needed to just figure out the sine of 75 degrees real quick. But another way is to use this addition formula for the sine function. Right, so what I need to do in order to evaluate sine of 75 degrees is break that apart into, or break apart that 75 degrees into two angles that are added together that are angles that I know the sine and cosine of. So what I would break these into would be 45 degrees plus 30 degrees. Right, because 45 degrees I know from my trig hand, 30 degrees I know from my trig hand, or if you have the unit circle memorized, they're both in that first quadrant of the unit circle. And so if I break it apart this way, well, so the 45 degrees is like my S, the 30 degrees is like my T. And if you did it backwards than what I did, if you did it like 30 plus 45, you'll get the same answer in the end. So you'll have different numbers in different spots here. But since everything up there in the formula is multiplication and addition, the order that you put the S and the T doesn't really matter. So if you did 30 plus 45, your steps would be a little bit backwards from what I have, but your final answer would be equivalent to what I get. So the order you put these doesn't matter, is what I'm trying to say. All right, so sine of 45 plus 30, right? 45 plus 30 equals 75. So that equals, all right, so it's sine of S, so it's going to be sine of 45 degrees times cosine of T, so sine of 45 times cosine of 30 degrees, plus cosine of S, so that's going to be cosine of 45 degrees, times sine of T, so that's going to be sine of 30 degrees. All right, so there's my setup for my formula. All right, just the S and the T, just putting each one where it belongs in the formula there, and then I just need to evaluate each one of these things, right? So that's why when we do this, we have to break it apart into values that we know. Like I could break 75 into 70 degrees plus 5 degrees, but I don't know the sine of 70 degrees, I don't know the cosine of 5 degrees, so it's not going to help me to do that, right? It has to be broken apart into like 45, 30, or 60, or 90, or numbers that you know from the unit circle or from your trig hand. All right, so let's do this part where we actually put all the numbers in place. Sine of 45 degrees, right? So 45 degrees if I use my trig hand, and if you haven't seen the videos that I did about trig hand and the unit circle, you might want to check those out because it's a real easy way to evaluate stuff like this. Right, sine of 45 degrees. 45 degrees is my middle finger, right? That's the one that's halfway through the first quadrant. Sine is the y coordinate, which is given to us from the number of fingers below. So the sine of 45 is going to be the square root of 2 over 2. All right, so it's root 2 over 2. All right, cosine of 30 degrees. 30 degrees corresponds to my ring finger here, and cosine is the x coordinate, which is the number of fingers above, so that's the square root of 3 over 2. All right, plus cosine of 45 degrees. All right, here's my middle finger is 45 degrees. Cosine is the x, the number of fingers above. That's square root of 2 over 2. And then sine of 30 degrees. 30 degrees, once again, is my ring finger. Sine is the y, which is the number of fingers below, which is 1 over 2. Right? And if what I just did there with my fingers doesn't make sense, or if you don't know these values already from the unit circle, like I said, go back and find the video that I did on trig hand and the unit circle, and it'll make a lot more sense how I just got all those numbers pretty quickly without having to like actually draw the unit circle and fill in a bunch of numbers. You can just use your fingers real quick and get the values you need. All right, so I got all this. Now I need to simplify. So square root of 2 times square root of 3, that's going to be the square root of 6. 2 times 2 is going to be 4. Right, remember, when you're multiplying two square roots, you are allowed to multiply the numbers underneath the square roots. And then over here, square root of 2 times 1, well, that's just going to be square root of 2 over 4. Right, 2 times 2 gives us 4. And then these two fractions have the same denominator, so I can add them together. Now here, the square root of 6 plus the square root of 2, that's not the square root of 8. Right, remember, we can only multiply or divide numbers in square roots. Adding numbers or subtracting numbers in square roots, we cannot just combine them together. We can only do that if we have the same numbers inside the root, and then we add the numbers on the outside of the root. So like if I had 2 square root of 3 plus 5 square root of 3, that would be 7 square root of 3, right? Just like 5x plus 2x would be 7x. That's the only way we can add and subtract roots. If we don't have common numbers inside the roots, then we just leave it as the square root of 6 plus the square root of 2. Right, so root 6 plus root 2 over 4, that's the exact value of the sine of 75 degrees. All right, whereas if I use my calculator and I do sine of 75, just to show you what I get, right, for my calculator, it's not going to give me square root of 6 plus square root of 2 over 4. It gives me the decimal form of that number, which is 0.9659. Right, so the advantage of using these addition and subtraction formulas is if you need the exact value of sine of 75 or cosine 75 or whatever it is, if you do this formula and you simplify it, you can get the exact value. Right? If you just use your calculator, it's not going to come out to the exact value. So just to double check this, I'm putting in then my answer, square root of 6 plus the square root of 2, all of that in the numerator divided by 4. And when I put that one in, as you can see, I get the same value as just sine of 75. So that confirms that I did all the work correctly here and I got the correct answer. All right, so again, addition and subtraction formulas, we just did the one example of the addition formula for sine. But if you understand how to do that, you should be able to do any of the other ones. It's just a matter of breaking apart the number into angles that you know, and then just putting them all in the right spot according to what the formula says, and then just evaluating each one and simplifying and doing all that work there. Again, the advantage is it gives you exact values, whereas putting it in the calculator just gives you a decimal. So that's a good thing. So that's our addition and subtraction formulas.